So here we have the flying example template that is provided with Unreal, and I just add this block here that will simulate a missile launcher, and that will spawn a missile that will follow the flying pawn, and it will spawn another one if the missile that is currently following reaches its destination. That means hits the flying machine, or if it hits any wall, get destroyed, and the the missile launcher will spawn another one. So I will run this on simulate so we can see the behavior. You see it spawns a missile and it follows the flying machine. It hits and it will spawn another, and it will follow again. It fixes its orientation into reaching the flying vessel, and another one was trying to. This one is more interesting. It fixes its orientation and it follows the flying vessel. You see here I attach a camera to the missile, and we can see what the missile sees when it's approached its destination. This one is more harder, but at the end it reaches destination. You see? So okay. So let me explain how this works. Well, for the missile launcher, I won't explain that a lot. It's just a spawner that will spawn a new instance of the missile as long as if there is none in the scene. That means if there isn't any missile in the scene, it will spawn another one. And when that missile gets destroyed, it will spawn another. So this is pretty basic behavior. I won't explain that. The real following algorithm is done here in the missile itself. So I will open this blueprint I have here to see what it contains. You will notice that one of the components here is this yaw pitch PID controller. This is nothing else than another version of the camera PID controller that I explained in some videos before. This yaw pitch PID controller will control the rotation of this actor. First thing I do here, or you will notice, I have an actor to follow. In this case, the actor to follow is obviously my flying pawn, but I pass that as a parameter. So the first thing I do on begin play is create two PID controllers, one to control the yaw rotation of my missile, and another one to control the pitch rotation. Next step is the PID initialization. I take each PID and I initialize its minimum max values. Since the variable I'm controlling is an angle, this varies between minus 180 and 180 positive. Next thing is to set the PID coefficients. For this control, I only need a proportional effect, so that's why I only have P coefficient of 20. And then I do the same. Well, this value is trial and error. You start with 1 and increase to having a good response in terms of speed. I do the same thing for the pitch PID controller. Set the limits of the process variable and the coefficients, and that's all. Next, each tick Here, the first thing I do is to check or validate that I have an actor to follow, if it is valid or not. The next thing is to take that actor and I make a computation of the vector from my position, or the missile position in this case, to my actor to follow. And that way, that will be that vector will be my target orientation, my target direction. So you see, I get the actor to follow location, I get my location, make the difference, I got a vector, I normalize that vector, and that will be my orientation that I have to obtain, the orientation that I want to follow. So then I pass that to a function that will compute, that will use that vector, that will use also my current direction, and computes the yaw rotation that I have between those two and the pitch rotation that I currently have, my yaw and pitch angles. I want those angles in a steering application, I want those angles to be zero. So my next step is process PIDs. I take the yaw PID to control that angle, and I pass the yaw angle. I want the reference to be zero, and that will produce an output an angle that I have to add, or a yaw rotation that I have to produce on my actor to uh, align the actor or the missile in this case to the target. I do the same thing for the pitch PID. I pass the process variable, which is my current pitch angle. I need that to be zero, and that produces a pitch value that I have to add to my missile in order to align myself or align the missile to the target. Next thing is just apply that rotation to locally. You see this is doing nothing. I will remove that. I'll remove that right away. For a minute. I apply this rotation, this pitch rotation and yaw rotation, to the actor, in this case the missile, or to myself. And that's all. That's what this component does. Yaw, pitch, PID controller. Here, and that little window in the lower right corner, you can see what the missile sees. I attach a camera to the missile, and you can see what they see. So you can have like a sense of where they are. So you see, they see me and try to follow me, and they hit me. They try to evade. So this works. The other type of control that we can have in these missiles are the control of the speed, or the velocity, or the forward velocity of the missile. If you see the missile blueprint I have in the project, there is two options. The default two options to control the speed. The default behavior is to use a constant speed. So what I show you to this point is that the missile goes in advance to in a constant with a constant speed in the forward direction, which is not realistic, but is good enough for games. I mean, So with that default behavior, what I do is basically I get the current location of the missile, I get the forward vector, and I just compute the next position using the speed that I want to, that I set that speed via parameters. So using the speed and those that information, forward vector, current location, I compute the next location and I simply update the location of the missile. And it's as simple as that. But we also have the option of using physics thrusters. Physics thrusters are like propulsion jets that are attached to the missile. So if you see here in the viewport, I have, or in the components, I have a physics thruster pointing forward, a side thruster pointing to the side, and a up thruster pointing up actually. So the physics thruster with add impulse to the middle in the forward direction. The side thruster will add an impulse on the right or left direction, and the up thruster up and down. It's as simple as that. Now, my objective of control with this thruster is that the physics thruster will add force that will keep my missile going forward at a desired speed. The side thruster will add a force that will keep my missile with zero speed on the side, or lateral speed of zero. And my up thruster will add a force that will keep the same as the side thruster, will keep a zero speed or zero velocity up and down. I want my missile to move only forward. So with this, I can use 3 PID controllers to control each one of these thrusters in an independent way. Now we go back to the event graph, and to do that, all I need to do is the same thing as always. In order this actor to follow is to pass to the missile an actor that I have to follow, my target actually. In my component, Joe Pitch PID controller. But well, let's skip that part. The important part to control velocity is the PID creation. I create 3 PIDs, one for each direction. Up speed PID, speed PID is the forward, and side speed PID. Then the PID initializations, same thing, the max and minimal value of the process variable. Then the coefficients is here you see a super big value for the proportional coefficient. That is because there is a conversion that needs to be done from speed to force. But you can perfectly have a smaller value here and just apply or make the multiplication, or at the end in the output when you apply the force actually to the physics thruster. And you do the same thing for each one of the PIDs. Set min and max values and the coefficients. The coefficients usually are the same. Then, well, I need to measure the speed each frame or each date. So I initialize the variables for the current and previous position in order to do that. Now, in the update, this is a security measure just to if my values show in pitch PID controller or my target hasn't been initialized, I make the initialization here, but that is done just once. This is to allow to use constant speed or use the thrusters. in the case where I use the thruster, what I do is measure the speed. This function will measure the current speed and update the up speed, the current up speed, the current side speed, and the current forward speed. Then I process the PIDs. What I do is for the side, the up speed, I get the current up speed, and I want that to be 0. Again, I don't want my missile to move up and down. I just want it to move forward. And I produce an output that I will apply to the thruster. Same for this is the forward PID, the forward speed PID. That one, I don't want to be 0. I want that to be my desired speed. So I get the current speed and I pass as a reference the desired speed. That produces an output that I can apply to the thruster. And last, the side speed, that one, I get the current side speed. I want that to be 0 again, and that produces the force to apply to the thruster. Last thing, what I do is apply those forces to each thruster. And that's all. So let's see how this works. Well, in order to use the physics thrusters, the control by using the physics thruster, I have to make sure that they are auto-activated, the 3 of them. And the other thing is that this variable, constant speed, is set to false. This way, I don't going to use the constant speed settings. I will use the PID instead. We'll compile that. In this way, we can already use this mode. So let's see how this works. I'm putting myself in a position where I can see the behavior. And you see, here I see the ball. And you see here they actually are controlling the speed in order, since this is a more realistic simulation, because I'm using physics here, they increase the behavior. However, they go a little bit slower because they have to make a multiple correction of the speed in different directions. But it's solid. So what I mean by solid is they reach their destination with success. I will try to move to play a little bit with the vessel, so you can see how they follow the flying pawn. So let's go to. So you see in this little window, you can see what the missile is seeing actually. So you see they fix their orientation, they follow the vessel with success. So feel free to get this project from the GitHub link that I will provide you in the description below. And if you have any question, don't hesitate to ask.